they all have helper listed in front of their name. So send them a chat and we can make sure that we get everybody up and going before we take off. All right, so there's still several people joining in. So if you're just now coming in the chat window, there is a link to our HackMD page for this session, and it'll give you the getting started steps to get up and running. For those of you that are working already, once you have a page that looks like what I have on my screen here, go ahead and give me a thumbs up or I'm ready to go in the chat window so we can kind of keep track and make sure that we're not leaving anybody behind from the get-go. All right, again, a few more people have joined. So there is a link to our HackMD page for getting that up and loaded. I see lots of people giving a thumbs up here, so things are working. This is good. If you're having any issues, please reach out to somebody that has helper in front of their name. They'll be more than happy to get you going and get you set up. All right, so I'm going to take it that I've seen lots of thumbs up. I haven't seen any messages in the chat. I'm going to take it that most people are up and running. If it's not, you're going to be able to follow right along with us. So I'm going to be working on the same sheet that you guys are working on today. So the notes will be on the screen, no matter if you're looking at your own version and your own copy, or if you're looking at the screen that I'm sharing and it's my copy. So my name is Drake Asberry. I'm a PhD candidate here at the University of Arizona. My specialization is second language acquisition and teaching. I started out in Python a long time ago when people made fun of me for learning Python because they thought it would never be anything. Working with geospatial mapping and stuff, and it's something that stuck with me for many years later and something that I use quite often in my own research, my own projects, and just trying to make life a little bit easier. So this morning we're starting from 0. So if I could just get a show of hands, how many people have had any programming experience, whether that's Python or maybe R, There's some other ones out there. All right, very good. So we do have quite a few people that are raising hands. All right, we got some R people. All right, perfect. All right, so we have quite a bit of experience. We're probably about half and half. So all those people that just raised their hands, feel free. The beginning will be a little bit basic. We're going to talk about some of the basics of how the code is structured, what we're doing, how we're storing things. And so there's a whole another half of this group that hasn't got any coding experience at all. So feel free to ask questions in the chat and also participate as an audience member. Answer those questions. We have helpers, but this is a community and that's what we want to foster. So if you know the answer, or you see something that got missed in the chat by me or one of our helpers here, answer it. That's what we're here to do. We're all here to learn. And so with that, we'll go ahead and get started. So the table of contents, this is just for later reference. You guys can come back, click around, move through, but over the next 4 hours, we should be able to get through, I'm going to say 80 to 90% of this. We probably won't get through everything here, but we'll work through it. And then the solutions are all in this notebook as well. So even the things that we don't get through today as a session, you will be able to get into and look at, see the solution that we have available. So what are Python programs? It's one of the big things that we don't think about. We write something and it does something for our computer. So basically what they are plain text files. So we are writing our code, which is basically us giving a command to the computer. So many of you guys have done some other things like MATLAB or R, same concept, just a slightly different language. So this would be like the difference of speaking English or Spanish or German or French to the computer. So we're now using a different language to communicate and give the computer a command as to what we would like it to do for us. So Python files are pretty easy. The convention is to use .py as the extension. So it's a good way to identify your Python files. This is a convention, it's not a requirement. Extensions don't really mean anything. So by convention, we use py for Python files. We use .r or for R files, we use .rnd for R markdown files. We use .mds for files or .docx for a Word document file. These are the conventions that we have set out, but the computer really doesn't care for the most part. So generally we would write these in some sort of text editor or an IDE. Here today we're using what's called a Jupyter notebook. And so this is something that we have used when we're doing virtual stuff because it's hard to troubleshoot dependencies and problems with installations and whatnot. And so using a Jupyter notebook and in combination with Binder allows us to basically run everything that we need in here, and we don't actually have to install anything on our local computers to do that. If this is something that you're going to do on you're going to start working this into your workflow, you'd want to think about doing the second half of our tech requirements, which is basically getting this stuff that's downloaded on your local machine so that you're working here. But Jupyter Notebooks is still a great place to play around and go. So quite often, you're going to see something like this pop up throughout the day. It says, hey, the kernel's dead. All right, don't freak out. Just hit try restarting. And it should go back. And then that went from no kernel to kernel ready. This is going to happen periodically throughout. And so what we want to do in case it goes dead and we can't get it back is we want to use this button here, which is save to browser storage. So use this button frequently, and then it'll come up and say it's going to save here. And this is saving to your browser storage. So if you do get kicked out for whatever reason and you have to reload everything together, again, you can come in and say load from browser storage, which is the button just to the right of that. and it'll remember everything that you've run in this notebook thus far. Okay, so if you do get kicked out, just restart, follow those steps in the getting started, come back in, and we'll be ready to go. So Jupyter Notebook, the nice thing about this is that it allows us to combine a lot of text in a markdown format and code. So right now we are in a big markdown cell that we can see listed here as markdown, and we have a couple of different types. The two that we'll use are markdown and then code. So for markdown, this is where you can actually take notes. You can add your own cells in here, add your own notes as we're going, and you're just typing right in this notebook, and you can save it. Code, we'll also be adding some code cells, and we'll actually be typing in Python code and executing that code and seeing what those outputs are doing and solving errors, et cetera, as we run into them. So here are some shortcuts that we will be using. They're good to use. So notice that this box is blue on the outside. This means that I'm in command mode, which means I can move around the notebook. I can go from cell to cell, but there's nothing to execute here. If I click on this, I can activate it and make it go green. And this is the markdown code behind here that's showing us this pretty output when we hit run. When we run, it takes us down to the next one, next cell. So we've just redone the markdown, looks all pretty again. And now we're here, we're ready to go. And we get to our first code cell, all right? So you can click run for these, or you can hit shift and enter on your keyboard, and that will also run it. So if everybody wants to try to run their first cell, here we are down here where it says find the shortcut to run this. So we can click here, or we can hit run up here, or we can hit shift enter on our keyboard. So notice that this little 1 appeared. If you got a 1 in your cell, please raise your hand, say, yes, I got it, we're good to go. Just want to make sure that we have people executing cells appropriately before we move on too much further.
Drake, there is a question in the chat. Alma asks, what is Binder? Why do we need it along with Jupyter Notebook?
So Binder is what we're using just as a teaching platform. So if we weren't using Binder today, you guys would have had to install Anaconda. You would have had to install a couple of other things that were going on onto your local machine. And I gave instructions for that if you wanted to go that route. However, Binder prevents all of this necessity from happening. So I've set up all the requirements and I've got all the packages that we're going to use today. And you haven't had to do anything on your local machine. So this allows us to execute code that's open to the public. So my repository from GitHub is open and it's not private, or there's no restrictions on it. Anybody can go find it. And then they can open this up and then they can run this in Binder without having any know-how about how to install Python on their computer or Anaconda or Jupyter Notebooks, etc. So this is just a teaching tool for us today. It is not necessary to use Binder ever to do coding or Python or anything like that. But for teaching and in a workshop environment like this, this has been the most stable tool that I have found that helps people get everybody off the ground and moving. Does that answer the question, Chen?
Yeah, that answers it.
Okay, perfect. Yes, and I see somebody else is saying that you can also use Jupyter without Binder. You absolutely can. And so we've forked the repo so that we have our own copies to save for later. We can go back and review them. Yeah, absolutely. So I saw a bunch of things. So we ran this code cell. Everybody got a 1 there, but nothing nothing really happened except for that one that showed up. So this first cell, all it did was create a variable. So a variable is something that we use to store information and that we can use later in our program. So we're going to name this variable whatever we want. I highly recommend that you give it something useful. Lots of times we'll name things like X, and then we don't know what X actually is anymore when we have a problem. So giving an informative name will help you debug things along the way. So what this did was it told the computer to store the text, run me first, as the value of message. So if we go down to this next code cell, all right, and we execute this one, we're actually going to be able to see what the computer thinks message is. So we're going to run that, and we should get a 2 that comes up in this box saying that it has been executed. And we see an output. It says run me first. Okay. Let me see a show of hands that everybody has successfully run this using whatever means necessary. A thumbs up. Okay, I see some thumbs ups happening here. All right, great. So what are these numbers? Does anybody have any idea as to what these numbers are symbolizing already? And are they able to unmute their mics here?
Yeah, I think everybody's able to unmute.
Okay, yeah, so feel free to unmute and chime in, ask questions as well. But we got a binder tab froze. All right. So Jay, you could be, you can refresh that page. It may reload. You may have to go back to the My Binder and paste the link. And then you can restore from the browser storage. So, all right, so we don't have any brave souls this morning. So this is the order in which we've run the code. All right, here is the link somebody's asking for the setup. So this is something different that happens in Jupyter Notebooks that doesn't happen when we're using other types of things on our local machine, writing in a text editor, writing in an IDE environment. So code is generally ran from top to bottom. So the Jupyter Notebook will allow us to go back and edit this cell. Okay, and then I can type in a whole bunch of stuff here. And what'll happen is that when I execute this cell again, it's gonna give me the same answer. And it's because I haven't run this cell to give it the new value yet. So Jupyter Notebooks allows us to mess around with things, but it can also cause us some trouble. So be very careful in paying attention to the running order that you have. So I ran this on 3. Okay, so step 2 was probably this. And now if I go back up, I can rerun this cell. And now that's step 4. So this is my run order. So now when I print my message, I will get all this extra stuff that I typed in there. So this is just something to be aware of with Jupyter Notebooks. That you can run things out of order and it can cause more confusion sometimes. So get in the process of, even when you're in a Jupyter Notebook, running from top to bottom. Try not to go back and like edit things above unless you're debugging, and then you run wherever you find the problem, you run that cell and you run every cell below it until you get back to where you were. Okay, so everything that we have here is up and running. Do we have, does Python have a graphical user interface like RStudio? So there are some things, there are IDEs, and PyCharm is the one that I use, and then somebody else has already put that in the chat window there. So there are things that you can use that have more of that graphical user interface that maybe makes it feel a little more comfortable if you're migrating from R, doing something like that, not just all this stuff at one time. And yes, so PyCharm can have a pretty powerful learning curve. Spider is another common one. Julian, I see you here. Do you remember the, you have a link to that one we played with a couple weeks ago in Coffee and Code, the very, very small basic one?
Yeah, it's funny. I'll paste the link one sec.
Okay, thank you. And so if you want to avoid that, Julian's going to post us a link to another one it's very basic, but it's quite powerful and it's pretty good as it helps you out like learning what's going on. And so there are things that are available and it comes down to a preference. What are you used to? So there's no right or wrong way, and there's no kind of standard, like everybody that's doing R is generally working in RStudio if they want that graphical user interface, because it's widely supported by the entire community. Python, we have a lot more variation. There's a lot more things that are out there, and it comes down to personal preference. Yeah, so you see people are still putting in other options where they write their Python code. Very good. So Markdown, I saw quite a lot of R users here. So Markdown is a way to format text, giving basic instructions. For our purposes today, I included this section so that way we can see it. And if you want to go back and make things pretty later, you have some examples of how to make lists, how to use special characters, how to make numbered lists, do different headings, things that I used inside of this document in the preparation. But we want to get to Python. We're not going to worry about Markdown so much. The important thing is that if you create a new Markdown cell, we're going to jump down, okay, to here, and I want to make a cell. I want to insert a new cell below. I just hit the B key, or you can go to insert cell below, and you see the shortcut key listed here in the menu. So the default is code. So if I go to Markdown, I can write, anything. You just can type. And this is all we really need to know for today, is that you can write kind of your notes that you want to interject into your own notebook. So these are my notes. And I'm not sure I need anything else. Okay, and then we would just run that cell, and then it becomes text as part of my document. Oh, and PyCharm does have an EDU version, and they do have some lessons that you can get. Yes, so lots of good suggestions in the chat window there, guys. So here, these are Markdown and the Markdown exercises, but this is our first start of Python. So Python, we can run these code cells, and we can run it just like as a calculator. So we see what we have here. We have 7 times 3, and the output comes out at 21. So go ahead and start running these with me so that we can see what's going to happen here. And basically all this did was simple multiplication. And so we just told Python, hey, I want to know what the answer is to 7 times 3. We run that cell, and then Python gives us the answer. All right, what's going to happen if we run this next cell? We have 7 times 3, we have 2 plus 1, and we have 6 times 7 plus 12. What is the output going to be? So if you guys could type the output in the chat, what do you think it's going to be before we run it? Okay, I see. Okay, I see multiple people saying the result. Some people did the math in their head. Some people were like, it's going to be the result of this thing. I have a computer for me. Like, I'm going to let them do the math. Okay, good. So why is it going to, oh, okay, 3 different numbers? All right, so let's run the cell and see what the actual output is. Okay, comes in and it says 54. Okay, so why do we not have 3 different numbers? Did it calculate 7 times 3? Did it calculate 2 plus 1? And did it calculate this thing? And the answer is yes. It calculated all 3, but it's only displayed the last one for us. And we see that coming up in the chat. So very good. And the same thing happens down here. We could say, hey, this is the actual equation that I want to store. All right, and so this is what my value of x is going to be. So just like we put text in a variable with message before a string, we can also store numbers as variables as well. So if we do this, we get down here and we have a print command. And so basically, I'm going to comment this out for a second. And Python uses the pound sign as the comment feature. So if we run this, what do we think our output is going to be? So in the first box, we ran all 3, we calculated all 3 and we reported the last one. Okay, so we have some people saying the value of x, we have people saying nothing. Okay, we have people saying 3, says, okay, the last calculation that I did that wasn't in a variable, I'm gonna get that answer. All right, so let's go ahead and execute that. All right, and so I have an 8 here, says that it ran successfully, but I got nothing in my output. So the last line that this cell ran was storing a variable. All right, we didn't ask the computer to tell us what that variable was. And so that's where print commands come in. So I'm gonna uncomment that and make it active code again. And so now I'm gonna tell the computer, print on the screen for me what the value of x is, okay? And so when we run this, all right, we get our expected result, 54. Is there a question? Okay. All right, so very good. So we get 54 now. And so what do print statements do for us? Why are they useful? So something we'll use a lot when we code, not only today, but in any point in time. You guys can unmute and speak if you want, if that's easier than the chat. All right, so very good. So we assume that the variable x is stored as this equation that we gave it, right? But that's an assumption. So this allows us to check that assumption. So when you're coding and you get down and you get to the end of your script and it's giving you a number or a result that you don't expect, this is a way that we can kind of view in at different points of the code and say, hey, what do you actually have here? And we can start to narrow down the places where we need to find where an error may have occurred, or we overwrote the variable with some different value that we didn't realize that we had done. All right. So this is super important. You'll use these all the time. You'll see them commented out in some of the code that I have today, just to show that like we use these a lot to get into and see what we have available to us. So what happens if you change this to a markdown cell? What do you think would be the outcome? So if we go up and we change this to a markdown cell, and then we execute this. All right, it shows up as text, right? So when might this be useful to have the stuff that's behind the scenes. Okay, when you're teaching, right? This could be a really good thing. Or how does my code work, right? You guys can look at my Markdown code and say, oh, there's a whole bunch of stuff in there. And when I execute this, it doesn't look like that anymore. There's a link there. When you're sharing it with others, right? How many times have you walked into a meeting and your advisor is like, or your colleague is, well, how did you get that? Why did you do this? This gives you a place that you can say, this is the code that is behind what I'm running. This is the output of my code. And in a teaching format like this, it might be a little clearer to look at something on something that looks like a web page versus an IDE or RStudio. Because these can be unfamiliar spaces and daunting spaces for people to be in. All right. So then we can also use equations. And I'm going to let you guys run through these instructions really quick, but think about this equation. What will this thing display? What do these symbols mean inside of the equation? We have underscores, we have carets, and we have dollar signs. These are telling the computer certain things. And I'm going to run it with the error. And so Python says, I don't know what to do with this, right? So it says you have a syntax error. This dollar sign, okay, I don't have any idea what to do with this. And so it says invalid syntax. I don't know what that is. But Markdown will allow us to do this. So if you were like me and you made a mistake, and you got this weird error message. Okay, you start looking at these things and you're like, okay, what is this syntax? Syntax is anything, spellings, typos, using characters that the language doesn't understand, etc. So we're going to go back, we're going to change this to a Markdown file or Markdown cell, and then we're going to execute that again. And then we get a nice looking equation that's printed out quite beautifully. So we see that underscore, okay, is a subscript. Okay, the caret relates to a superscript. Okay, so we have lots of different things. And the dollar sign at the beginning and the end just says, hey, Markdown, I'm getting ready to give you an equation. So, and I want you to format it and print it as an equation. It's not just random gobbledygook that I typed on my keyboard. Okay, this has meaning. All right, so we're not going to do any of these exercises, but does anybody have any questions about what we've seen so far? We've executed Markdown, we've executed code cells, we've seen a variable stored as text, so run me first, and we've seen a variable stored as a number. So if you're good to go, give me a thumbs up or a wave or something. All right, I see him coming up. Good.
So in that case, do you just delete the dollar sign? Since it marked this error.
No, so I didn't delete the dollar sign. What I did is, so I'll go back to the code. So the code is there. So the dollar sign is in here, but the difference was that when we tried to run it as code, Python says, I don't know what this dollar sign means. Markdown is a different language structure. So we switch it to Markdown. And Markdown says, oh, I have a dollar sign. Where's the next dollar sign? Everything between these two dollar signs is an equation that they want me to make pretty, basically. So we didn't delete anything. We simply changed the cell type from code, which will give us an error because Python doesn't understand this language. And we change it to Markdown. All right, and then when we execute that Markdown says, hey, I know how to do this.
Thank you.
Yep. So the curly brackets are being used in the subsets, and so they're keeping them all together in that subset. And so that's why we can have I equals 1, and we can have N go up as a superscript, etc. So yes, the different, I think it looks like it's curly brackets are representing the parentheses in the equations, and you are correct in that. And so we don't necessarily have the parentheses written here, but we could have put parentheses in that formula as well. Okay. So let's get to some Python. So here we are, we're on the intro. So what we're going to do today is basically learn about what is Python, what does it work with, how does it work? So what things do I have available to me? And we're also going to be cleaning and manipulating some data that we have and learning how to write very, very small and simple things that serve as the foundation or the building blocks of much larger programs and data analysis that you may be doing in your own research. All right, so we're going to use pandas. There's a whole nother session on Wednesday that dives into pandas in a much deeper sense than what we are going to see today. But we are going to use pandas as our basis for doing some of these things today. All right, so why should we use Python? Python, like R, also has a pretty big community of support. It's widely used in science. The code itself is fairly human readable. Some computer programming languages are not. They're really hard to interpret and figure out what's actually happening. Python is fairly easy to read, even in its code format. There's a huge community, which means there's answers all over the internet, and most of the time, more than one answer to the same problem, approaching it from different ways. And as you get more proficient, you will be able to learn how to decide which one works for you in the context in which you're working in. So most programming languages will have special characters, which means that the language interpreter says, hey, when I get a square bracket, that means I'm looking for something else. I'm expecting this thing to come back. And so if you need to actually use that in your text, you'll have to escape it. Python's going to use the backslash, right? And so if we need to use one of these symbols in our actual code for some reason or another, we will be escaping these out. The escape character will differ between languages. For Python, we're going to use a backslash. And so we're going to see as we go through today what Python expects when we give it square brackets, what Python expects when we give it parentheses, what Python expects when we give it curly braces, and other symbols. Okay, so double quotes and single quotes are going to be one of the most widely used ones that we have for doing strings and whatnot. So variables, as we've seen, we've done one with integers and we've done one with strings. So we have a name and we assign a value to that name. All right. So there are two things that it can hold. It can hold basic data types, which we're going to go through. We're going to see strings, integers, floats, Booleans, all of these types of things. We're also going to see that it can be a way to structure objects or the actual data and the code that's going to happen inside of a larger program. There are some naming conventions. So you cannot start a variable name with a number. Okay, so you have to start it with a alpha character, and it cannot contain spaces, and it cannot contain quotation marks or any other type of punctuation. Okay, as I said earlier, it's best practice to use a descriptive name so that later when you're trying to use that variable and understand what it is, you'll remember, oh, that's the, that's the age, or that's the last name of something, my user input. So we're gonna look again at a number and a string. So what do you guys notice about the difference between numbers and strings? Do you see anything that shows up as catches your eye? Okay, somebody said color, good. All right, I see a double quote or a single quote. Okay, good. So age is as an integer. We want it to be used. We may even want to do calculations off of this, right? We may want to find the average age of our population that we have data for. All right. The name, very unlikely that we're going to want to do any type of mathematical calculations on name. And so we put this in, and we can put any text that we want here. So when we execute this, it says it's done, but it didn't actually do anything. Why did it not give me any output? Okay, I said good. So we need a print, right? We got to tell it that we want an output. Okay, so it ran these. Our program now knows that age is equal to 34 and first name is equal to Drake, the text Drake. All right, so now we can give it a print command and say, hey, instead of printing out something specific, I want to print out, what do you think the variable is? So look at age, and it says, okay, age is 34, all right? And that's what it outputs. So this is working exactly as we expect. So I'm gonna give everybody a few 15, 30 seconds or so, and I would like you to do your first on the fly one. So using what we know here, write a print statement that gives me the output of first name. And then once you've done that, give me a thumbs up in the window once you've gotten an output. All right, seeing lots of thumbs ups. Okay, so what we need to do is tell the computer, hey, print. And what do I want you to print? All right, I want you to print the first name. So I'm going to type in the first couple of letters here, and then I'm going to hit the tab key. And notice that it completed the variable name for me. It knows that first name is a variable. And what this will help us do is avoid those syntax errors, those typos. So it's called tab completion. That'll help us. And if we have more than one thing that meets the criteria, we'll see a list of items that we can choose from. And we'll see that later as we get a little bit more complicated in our variable names that are stored in our notebook. So I'm going to go ahead and do that. And it should print out Drake. All right, and just as a friendly reminder, if people haven't done this in a while, it'd be a good idea to hit save to browser storage so that these things are remembered in your notebook in case you do get kicked out. So now what I'm going to have you guys do is I would like you guys to create your own variables. Okay, so in your notebooks, I want you to create one for yourself. So what is your age? What is your first name? Okay, it's probably not 34 and Drake. Okay, so I'm going to give you guys a couple of minutes to do that. And if you get done a little early, there's a little extra credit or bonus question on making the print statement a little more fun or easier to read by including it inside of a statement. So we have problem number 5. I'm going to give you guys just a few minutes. And once you're done, give me some thumbs up in the Zoom. And if you have any questions, put them in the chat. We'll answer them. We've got plenty of helpers, and we also have plenty of people that are trekking along and can probably provide answers as well. All right, so could I have a volunteer that would unmute and walk me through what we should type in this first box? No? Okay. So we're going to define a variable named age. Okay, you're going to put your age in it. I'm going to make up some things. All right, so first name, we're going to define a second variable. All right, and this is a string, it's a name, so we have to encapsulate it in quotes. So both single quotes or double quotes will work here. Either one will work. All right, and then, okay, and then I need to print out its value. So I'm going to give it the print command and say, hey, I want to know the age. I want to know the name. All right, and we see that we get this all together. So we print out both things. Each time we give it a print command, it gave us a print. All right, so if I want to enter a different age or different ages, do I need to number them or identify which one the program should print? Absolutely, that's a very good question. So what you guys are doing are overriding the practice data that I gave, or the example data, with your own data. So age is no longer equal to 34. And so if I come up and I run this, it's now going to tell me that age is 68. Because when we said age equals 68, it overwrote. Exactly. So you would use different variable names. My age equals 30, Drake's age equals 34, would store both. Okay. So thank you for that. That very good example there. All right. So we can also combine things into a print statement. We can print out multiple things. So say, hey, I want age and I want first name, and we just separate them out by a comma. And then it gets printed on one line. So by default, a print statement will put a space between the items in your list, and then it will go down to the next line for a following print statement. So in this, if we wanted to look a little bit more formal, say we actually want to like print this out on the screen for somebody to read, you know, 68 and Randy or 68 Randy doesn't really make a lot of sense. So we can combine this idea of putting more than one item in a print statement, and we can use the variable. So here we're going to replace this with our name. So we're going to say the value of first name, right? That's the first element that we want to print. Then we want to give it some grammatical sense. So we add in the word is. And then we're going to put the age variable. And then we're going to finish off that sentence with years old and a period. And when we run that, this gives us something that's very nice and human readable. So Randy is 68 years old. Now yours probably says something different. You know, whatever you put in is your age or your name is what's going to print out. So now we're starting to diverge. Okay. Any questions here? We've created our own variables now. Okay. All right, so the reason that we store variables is that we want to use them later. Okay, and so far all we've done is use them in a print statement, which doesn't seem very useful to us at the moment. But we can also use them in calculations. So what is this cell going to do? So I've assigned the age in my workbook as 68. So 68 equals the value of age 68 plus 3. So when I print this, it says my age in 3 years, and then it's going to give me a number. So it's going to give me the mathematical solution to 68 plus 3. So for mine, it's going to come up as 71. Okay. And so we've now used this variable that we stored at the beginning in a calculation that we've now changed the value of our variable. So what happens if we run this cell again? What do you think the output will be? Will it stay 71? Okay, I see no, it's going to go to 74. Okay, and so it's good. Yes, that's correct. It's going to go to 74 because now Python, this program says age is equal to 74 because I've already run it one time. So now it's 74 is equal to 74 plus 3. And so when we run this again, it's going to go up. Okay, so this is where it makes sense that we have to understand that we're tracking our variables and we know what we're doing. Okay. So what if you wanted age to stay 68 and you want it to create a new age for in 3 years? We could do something very similar. So we could say my new age equals age plus 3. So now we're defining a new variable to store the answer. Okay, and so if I change this to my new age. Okay, oh, we're doing all kinds of, let's take that out. So what that did is it added 3 to the age and then add 3 more to the age. So that's why we went from 74 to 80. But now it's going to be 80 every single time that we run it, because we're no longer modifying the original variable anymore. All right. So when we're using numbers or integers, math works in Python just the way that we learned in math class a long time ago. So the operations work the way that we have. Order of operations still applies. So if you have parentheses, it'll do those things first. Then it'll do the things outside of parentheses. If you have multiplication, it'll do multiplication before it does addition and subtraction. All of the math principles that are behind it are baked into the calculations used by Python. All right. We can also use a plus symbol when we're using strings. Okay, and this is called concatenating. So when we add strings together, what we're doing is combining 2 things to make a different thing. So here we have a name. We have Sonoran. This is the variable name. We don't have name yet. Then we have full name. And so we say full name is equal to whatever the value of name is plus desert. All right. And then we tell the computer to print out what do we think this is going to be. And so our output is the name Sonoran plus the word desert. Now notice that there is a space here. Why do I have a space here? And what would happen if I took it out? All right, so let's just do it for, okay, good. Jason's got it. So there would be no space between the words, all right? And then we come out Sonoran desert like this, all right? Which is sometimes like, hey, this is fine, not a problem. Yeah, Andrew's saying it would do a paste 0, so would not include the space, all right? And sometimes this is not a problem. This is exactly what we want, okay? But oftentimes we want a space in there. So we can do it this way, or we can actually add it in as a as its own character. So we literally just put empty quotes, add a space in there, add another plus sign, and now we're going to add name plus a space plus the word desert, and that'll give us Sonoran desert with a space. All right, so this is how we're going to start adding strings together. This can be useful for building text or doing text processing. Can also be good for building variable names. If you want to store a new variable name, or building paths to places on your computer where you want to output things without having to type in the path each time. You can use concatenation to build what we want. So let's go ahead and we've been at it for about an hour. So we're going to go ahead and take about a 5-minute break so people can get up, stretch their legs, grab a cup of coffee, and we'll start back at about it's 11:05 there. I'm in a different time zone, 11:05. And so if you want to start working during your break, you're like, I'm good. Go ahead and start working on problem number 6, and then we'll work on that together when we come back and build up a whole new system, and we'll keep moving. So take a 5-minute break, and we'll see you guys in a few minutes.
I'm gonna pause the recording now.
Okay, thank you. All right, so Izzy asked a really good question in the chat is, what is the benefit of moving to Python if you already know R? From my perspective, this is my own personal opinion, these two languages are moving closer and closer and closer to one another, where it's not as necessary to move back. So in most cases, the majority of cases, it's probably going to be your preference. What do you feel more comfortable in, and what do you feel more comfortable doing? For me, my workflow is generally I use Python for all the programming of my experiments, almost all of my data wrangling and manipulation. And then once I have the data in the state that it needs to be for analysis, I generally switch over to R. And I do all of my graphics and tables and whatnot from R, just because they integrate easier in what I'm writing my actual document in. So for me, that's kind of my workflow. If you talk to other people that know both Python and R, they may switch earlier. So my advisor prefers to do data wrangling and manipulation in R, not in Python. But Python is something that they know the basics of, and we have to program experiments in, but maybe not necessarily what he feels most comfortable doing for his data analysis and whatnot. So for in the broad scheme of things, I think it's mainly going to be a preference. So if you're, so yeah, Diana's saying she does everything in MATLAB and then does some graphics in R. So one thing, it's, you know, like why learn another language, like a, you know, a spoken language? Well, you gain access to a whole community of people that you can now understand that without that knowledge, you wouldn't be able to glean that information. So sometimes it just comes down to communication, which was a big point in the data science panel this morning is, you know, it's data science isn't all about coding. It's about being able to communicate those ideas, work interdisciplinary. And so even if you just have a basic knowledge of Python and your preferences are, right? Or you're vice versa, the other way around, you have a basic knowledge of R and your preference is Python, that opens you up to be able to have that talk and that communication with somebody that maybe is the opposite of you. So somebody that is more proficient in R than Python. You guys can have that conversation. In Python, you can automate easy stuff. Yes, you can also do the same thing in R. You can automate a lot of things in R nowadays. I see Kyle's putting in there, I use both Python and R. For all statistical modeling, I do it in R, web scraping, deep learning, machine learning, I use exclusively Python. Okay, you'll find other people that would say exactly the opposite. I do all of my statistical modeling in Python, and I do all of my web scraping and machine learning in R. You know, so they really are becoming one and of the same, just different ways of approaching certain things. So if you have something specific, more specific in mind, you know, there may be some advantages to one or the other, but in most cases, it's going to be a preference. All right, yeah. So yeah, it just depends on what you're doing. So there's lots of good things. Yes, and the environments are allowing a lot more things to be like, hey, I want to specify this is Python code or this is R code inside of the same environment. And you see that quite a bit. Jupyter Notebook is one of those things. We could do Python, R, or Julia as well. So these are all great points and a very good question. So one that we could talk about for days and never probably come to a conclusive answer on. So, all right, so let's do this print full name here. So I'm going to do a first name and I'm going to move away from the name that I made earlier. So I'm gonna put my own name back in there and my last name. All right, I'm gonna store this as a variable. And my last name is Asberry. All right, and then how do I print that? I'm going to use the print command. And then I'm gonna say first, and I'm gonna use tab completion and then last. Okay, and then I'm gonna execute this code cell and it should print out my name, my full name. Okay, I can do that. If I wanted to use my full name as a variable somewhere, I could also concatenate it and say, okay, I have my full name is equal to first name plus last name. All right, and then I could then put in the print full name. All right, and all right, I have a spacing issue. How do I get a space inside of my name in the full name variable? Anybody remember? Feel like sharing? Okay, all right, so I see, let's see this. So yes, we're going to add, okay, empty quotes. And importantly, what we need to do is put a space inside of those empty quotes. Okay, or we could add a space in front of last name. In the last name variable, but then I might not want a space at the beginning of my last name in other places, right? So this could work. It's a viable option. And depending on what we're writing and what we're going to use these things for later, one of those solutions will come out as the better one. Woods has added to the chat there. So add a space in front of the last name as a variable. That would also do it. Absolutely would. And we can test that. So now we have 2 spaces there because I added a space here. And that may be something that I don't want later. So I'm going to go back to that, and I have a full name and I have a first name and a last name with no spaces. Okay. So I got a type error. First name. String object is not callable. I don't see anything wrong with that. June, try to print just the first name. And Chun's got you taken care of there. He's a Python expert. All right. Try restarting Binder. I think your kernel is dead. All right, so we've seen 2 data types so far. We've seen strings and we've seen integers, okay? And so strings are any characters, words, sentences. They can contain spaces, they can contain basically anything that we think of when we write. All right, very good, sir. And then integers are any whole numbers, okay? So if we want to use decimals, we're going to get what is called a float or a floating point. And then if we want to do logical tests, so things that are like true or false, we're going to use Booleans. So these are logical things that are going to go. So we're going to look at strings a little more closely. So here in the strings, we can enclose them in single quotes or double quotes, and they do exactly the same thing. So you've seen me use both single and double quotes. They do the same thing. They all tell Python, hey, this is a string. So why in the world would we have 2 ways of doing the same thing? Because sometimes we want to use a quotation and it has double quotes in it, okay, and to execute in Python. And we need, in order to get double quotes in it, we have to put the whole thing in single quotes. So it says, hey, this is a string and the double quotation marks are part of my string. I want those to be included. Okay, and so we're going to take a look at a couple of different options here. So here we have no quotation marks. Okay, and the output just says the greeting is hello world. Okay, it's using double quotes. Here we're going to run the same code, so it's going to be in single quotes. All right, so we get the same output. So we can kind of verify that, you know, you're not just taking my word for it. We're looking at things in the output that we're getting from our code. And we're getting the same result, whether we use double quotes or single quotes. Okay. But sometimes I want a single quote to be in my string. So I want this quotation, the single quote, and this single quote to be part of the string that Python stores in the greeting. And so in order to do that, I use the opposite 1. So I use double quotes on the outside if I want single quotes in my string. Okay, and so what we'll see here is that that actually comes out, and those single quotes are printed as well. Okay, this is really important if you use contractions. So anything isn't, don't, doesn't, anything that has an apostrophe in it. You're gonna, if you want that apostrophe to be part of your string, you're gonna have to put double quotes on the outside. All right. And sometimes you might need to use both, and then you can use all the things that we've been talking about with print statements. So here, okay. So here, what we want is we want hello to be encapsulated in single quotes, and we want world to be encapsulated in double quotes. Now I can't do that in one string because I'm using both inside. So I can still print that though by storing them as variables. Okay, 2 separate string variables. So greeting 1 is hello with single quotes around it, and greetings 2 is going to be world with double quotes around it. Then what we'll do is we'll go back to our print statement and we'll print the 3 items, and we can get the output with both single quotes and double quotes inside of that string. Okay. All right, and we talked about concatenation already. We did that with first name and last name. All right, and we already know the answer to why there is no space here. Okay, because we didn't tell it to put one here. Notice I did the concatenation inside of my print statement this time. All right, this allowed us to not have a space inside. And then we have a new question. So why are greeting 1, greeting 2, bear, and down not enclosed in quotation marks in the print statements? And you can type your answer in the chat. Okay, so they are a variable. Okay, these variables contain strings. Their values are strings, but we're using the variable name. Okay, so the variable name is containing a string. All right, bear contains wild, the string wild, and down contains the string cats. All right, but we're using the variable names, not the actual string itself. Okay, so very good. All right, so. Strings are indexed, okay? And by index, I mean that each character has a number assigned to it. And Python is a 0 indexing language, which means that we start numbering everything from 0. Now this is in contrast to R, which starts at 1. So if you're an R programmer, this is gonna be one of the things that you're gonna find, you're like, why am I not getting the right data out? I'm 1 off everywhere I go. You probably started at 1 instead of 0. And if you're Python going to R, you probably get all these errors saying 0 doesn't exist. We start at 1, and you have to work through this issue. And it's gonna come up over and over and over again. I still do it all the time. And I'm like, so Python starts numbering at 0, and we have a string, and each character gets a number. So as we go from left to right, we start at 0 and we go up until we get to the end of the string. So we can use this to get information out of a string. So we have an atom name, helium, and we can use this indexing and say, I want to print this character. I want to print character 0, which is related to H in Python terminology. And I also want to print out character 3. Okay, so I find 3. Okay, it's actually the 4th character of the word, but it's I. So this should print out hi. Okay, because it went in and it said, hey, I found these indexes that I want to grab. I want to grab 0 and I want to grab 3. All right. So we could change these if we wanted to and grab a different index. We could say 4 and then 5. All right, we get okay, and then the indexing number is, this is what will throw us off, is we'll say, oh, I want the 6th letter of that word, and we'll forget about 0 indexing, and we'll get an error. All right, and it says the string index is out of range, which means that 6 doesn't exist here. Okay, and so looking at these errors, we say, oh, we see index error, right? We know that the error is on this line. Okay, there's something wrong here. There's an index that says it's out of the range. So while there's a lot of information that shows up, the more often that we get these error messages, the easier they will be to read and the easier they will be to identify the problems that we're working to try and solve. All right. So that's strings, numbers. Okay, we have an integer. Okay, we said it was a whole number. We have a float, which is a decimal. And then we can also assign a variable based off of another variable. So here we say, okay, my integer is 10. So just like we wanted to keep the original age variable earlier, and we wanted to put my age as a different variable and keep them both, we're doing the same thing here. So my value is equal to my integer. All right, and then I can print out my value and it will be whatever the integer is. So if the integer changes over time, my value will change over time. Okay, so let's go ahead and run this and see what our outputs are. My numeric value is 10. All right, so what happens if I change this to be equal to my float? What value are we going to have print out? All right, here we're going to get 10.99998. Right, because now we've changed what my value is equal to. We said, hey, my value is equal to whatever is stored in the variable my float. All right, and so we could put in another character here, another number, decimal point, and that change would be reflected when we rerun that cell. Okay. So sometimes we get data and we're not sure what type of variable it is. And this can be deceiving because sometimes we get numbers and they're stored as strings instead of an integer or a float. And so Python gives us a function that we can use to take a look and see what kind of information are we dealing with. So everybody has age and their first name listed here. And so we're going to look at the type and we're going to see what type of variable they are by using this type function right here. And we're going to put the variable that we want to know about inside of its parentheses. So when we print these out, we're going to get 2 lines. Uh-oh, age is not defined.
That happened to me as well. I think it's because when you restart the kernel, you need to run the variable assignment again.
Yeah, that could be the thing. So we can rerun it again. I'm gonna put it in here. And then if that is the case, I would expect that first name will probably have gone away as well. Yep. I'm not sure where we used first name, but we must have used it more recently. Or I overwrote age somewhere and removed it. Okay. So it says, hey, this is the class type integer. Age is 35, that makes sense. And first name is a class type string. Okay, so we see the types of classes. And then we're gonna take a look at the float and the integer. So my value is listed as a float. because of the code that we ran right here. My value equals the value of my float. So it's 10.999981. Okay, that's a decimal, that is a float. All right, so if we were to change this back to the original thing that we had, and we said, hey, we found the problem that we have. Okay, this was the issue. So we come up, we fix the issue, we run that cell, and then best practice is to run everything down below it until we get back to where we found our problem. And we say, now that's what I was expecting. I was expecting my value to be an integer because it should be an age. Okay. And yes, so people are asking, is there a way to do everything? So you go to cell and you run all above. So from the menu there, yep, and you'll run all from above, run all above, which means it'll run everything from to the cell that you are currently on, run all that stuff through. So thank you, Chun, for those nice explicit instructions on how to get there. And do remember to keep saving because it will save your output. And so all the stuff that you type will be saved when you reload and you restore from the browser settings if you get kicked out. All right, and our last type is Boolean. So this is testing things for true or false. Okay, so they're gonna be true or false. And so we're gonna set this. Notice that these are in green because Python understands this. Okay, this is a built-in of Python. So true is gonna be true. False is gonna be false. And these are built in, and that's why they get color coded differently in our syntax. All right, and let's take a look and see what we have. So my true Boolean variable is equal to true. And if I look at the type of is false, it also tells me that it's a Boolean. It's true or false. The value is currently set to false. All right, and we could change this variable to is false, and it would tell us that the variable currently is set to false, and that it's still a class of Boolean. So we'll do that just for reference point. And so we've changed what we want to print. It tells us what it is, and then it tells us is false, is still a class Boolean. So problem number 7 is what variable type do I have? So what I would like everybody to do is copy this line. And I want you to paste it down here in your next code block. And then I want you to use the type function to see what kind of variable this is. But before you run it, try and see if you answer it correctly and then check your answer. And then this will help us support our answer. So to check it, you'll do that. And then we would use the type function to verify our answer. So off the bat, what do we think the answer is? A, B, C, or D? Okay, I see lots of B's coming into the chat window. All right. Good. And so why is it a string? We have a number, it's a whole number, so it should be an integer, right? Okay, good. Because of the quotation marks. Yes, it's inside the quotation marks, and it says, I don't care what's inside of the quotation marks, it's a string. Okay, you can put anything you want in there. So we would use the type function. We give it the variable name that we are interested in, and we hit enter, and it says, hey, this is a string. So how could we change it to an integer? How could we get the type of size to be an integer? yeah, remove the quotes. So if we edit this, now our number turns green. So that's also another indicator that, you know, this is something that is recognizing. The strings are coming up in red text, the integers are coming up in green text, as was the true false for the Booleans. And now we see, hey, this is a typed integer. Okay. So this is a common thing you'll get an unexpected output, something like can't do math on a string. Okay. And you realize that somewhere along the lines, you made the numbers in your column that you're working with a string instead of an actual integer or a float if you need decimal points. And therefore, they're like, I can't do mathematical equations on this. You gave me a string. I can only look at, you know, I can look at indexing for you, but I can't do math. I can concatenate with another string if you want, but I can't do math on it. So this would be where you would go back, you would find your error, you would fix that error, and then you would rerun all of your code down to that point. And then you know that you're up to date, and then hopefully you're getting the expected outcome. All right, so we have some data structures. All right, so these are things that we can use in Python to help us do different tasks. So these are all fairly common, depending on what type of work you're working on. And we're going to take a look at each one of these as we go through. But the first one is a list. Okay, so it's a collection of values that are held together in brackets. And it says it's mutable. What does mutable mean? So mutable means that we can change it. So once we've created it, we can change it. We can add stuff to it. We can remove stuff from it. Okay, and so this is going to be in brackets. So if we look at the list item here, we see those square brackets. And remember that these were special characters for Python. And this is one of the uses of the special characters. So it says, we saw it in indexing earlier, but now we can also create a list. And when we create that list, we're going to use those square brackets. So Python knows how to interpret what A, B, and C are. And we separated each of the items in our list with a comma. So here we have a list of strings or a list of characters. Okay. So we also have a tuple or tuple. I don't know how you actually pronounce it. You'll hear it both ways. So I generally say tuple. And it's a group of values that are held together inside of parentheses. And it's immutable. So once this is created, it can't be changed. The only way to change it is to overwrite it. Just like we overwrote the variable age earlier, you'll have to overwrite the tuple to change it because it's using some things to be a little bit faster in processing with addressing and stuff like that. So if you're doing a really heavy computation, or large data set, tuples can be your best friend as far as speed goes and how fast the computer can compute what we have. All right. So they're within parentheses. Then we have a set. Okay. And a set is also changeable. All right. But it's the unique values. Okay. So inside of a set, you can repeat the same thing over and over and over again. But when you print out the set, it'll only give you each value one time. So if we had A, B, C repeated, and we said, hey, what's the set? It would give us A, B, and C, even though A is in that set twice, B is in that set twice, and C is in that set twice. It's only going to give us the unique values in that set of data that we have. And then dictionaries. So dictionaries are also contained inside of curly braces. They are also changeable, so we can add, subtract from. But what makes these unique is it works like a dictionary. So you have a key and you have a value. And so you can look up the values based off of a key. So just like when you open up a dictionary, you look up a word, the value of that word is its definition. We're going to use the same thing to create data to navigate through in Python. So these are the general types of data structures that we'll be using. And we have a list of characters is the first thing that we're going to do. And so everybody can go ahead and execute this command. And you'll see that the output comes out. The square brackets remain in that output. That tells us it's a list. All right. And we can also we can make a list of anything. Okay, so this is a list of characters. How would we make a list of numbers? So this is the next exercise. So go ahead and make a list of numbers. All right, once you've done that, go ahead and give me a thumbs up indicator that we got things working. All right, I see lots of thumbs coming in. All right, do we have anybody that's wants to unmute and tell us what we should write? Okay, I'll take the silence as a no. We'll go ahead and do it for us. We can see. Yes, the keyboard shortcut is going to be the shift and the enter key together. All right, and so we're going to go list. I'm going to say list of numbers. All right, and so I have to use square brackets to say I'm going to give you a list. All right, do I need to use quotation marks? All right, I love the involvement from my helpers. They're like all shaking their heads over there, like nope. All right, good. So we want integers here or floats. So I'm going to just say 1, 2, 3. 5. All right, and then if I want to print that out, I would have to say print. All right, and then I'm going to say list of numbers. So now I have multiple variables called list, and so now I can choose. So I'm using tab completion, and the pull down menu is here. So I'm going to say list of numbers. There we go. Yep, and then we can print that out. All right, and when we're in, I see some talk about the help menu. So you can actually, when you have a blue tile, so you're in command mode, you can hit H on your keyboard, and that will bring up the majority of the shortcuts in Jupyter Notebooks as well for the different modes. If you're looking for something particular. So that's just edit mode, and then the H key on the keyboard will bring up that menu. So I've printed out my numbers. I have my list, they're still in brackets. Okay, so I have 4 numbers, and there's no quotation marks because they're actual integers, and I want to do something with them. Okay, so just like accessing the values that were associated with the string, we can also access items in a list by their position. So we go back to the index again. And where does Python start counting? What number? Good, yeah, 0. So it's a 0 indexing language, so it's going to start at 0. All right, and so how would you print out the second value in the list of numbers? Okay, yeah, I see some people typing things in the chat. They're all looking good. So print that do the print command. We're going to say the list of numbers. And then we're going to give it the index. And the index is also inside of square brackets. And we choose 1 because that is going to be the second item of our list. And that says, hey, that's number 2. Okay, good. And so we see the second item is 2. That value came out as we expected. All right. And then because lists are mutable, that means we can change them. We can add to them. And we can use that with the append method, okay? So a method is similar to a function, but it gets attached to an object that we have. So our object is called list of numbers here. So we would say list of numbers, and then we're going to use a period, and then we're going to say append. All right. And then what do we want to append? We're going to append some number to the end of our list. Okay, so I'm going to add 10 to my list. You guys can put in whatever number that you want. All right, and then I want to be able to see that new list, so I'm going to print it after it's done. All right, and now you see that I've successfully added 10 to the end of my list. Okay. And a useful number or useful function that we have is length. Okay, so the length will tell us how many items are in our list. Now, this seems pretty simple right now because we only have 5 numbers. All right. But imagine you get a data set and it's got 100,000 data points in it. You want to know what the length of that data set is. You don't want to count 1, 2, 3, 4 to 10,000. Right? So length is a really quick way to look at how long is this list of items that I'm going to be iterating through. How do we delete one? That's a good question. So I accidentally added 10 twice. Okay. So how can we delete one? So this is where programming comes in really handy. Google's got a great answer, right? So let's take a moment. We're going to go and take a look and see what happens. So Python has a huge community. So we're going to remove item from list Python. I didn't even have to type it all. Okay, so it's a commonly asked question. So we'll go in here. All right, and we have remove. We have a remove method. Okay. And so if we look at this one here, it says, okay, we've got all kinds of information here. So we can say the object, our list name, so list of numbers dot remove, and we can remove the element that we want. So let's give it a try. Let's go back to our notebook. And all right, I'm going to add a cell above. And we're going to say list of numbers, which is our object. We'll use the remove method. And I'm going to put in 10. And then I'm going to print out that list again. Okay, and now 10 is gone. Now, Jung, I think you probably, if you run this on yours, you're going to lose both 10s. So now you have no 10 at all anymore. You have 1 10? Okay. So you could also use pop, which is to remove the last item. Okay, so we can do this. We can use multiple ways depending on what we want to do. And so we can add things in the middle. I don't cover that here. It's a little bit more complicated of syntax. We can find things if that's a question later as we get into the more hands-on section. Okay, so here, what happens when we get length of age? All right, it says, wait a minute, I don't know what you're talking about. So we have object type integer has no length. Okay, so this has no length. All right, so a string had a length, right? We could look at the length of things, and we're going to take another deeper look here. And we see that this is 18 characters long. So age has two numbers in it, you know, for me, 35. Okay, for, you know, if you're using a year, it might have 4 numbers in it. Okay, but if it's not listed as a string, it's a value. It's not a, we can't look at the length of that variable. We can look at the length of the list, can't look at age because it's an integer. We can't look at a float, okay, because it's an integer. We can look at strings, all right, which we see here. And this is also really useful. Like, how long is this string that I'm looking at? And maybe I want to do something in the middle of that string. Okay, I want to add a word exactly in the middle. So we could use some mathematics to say, this is my overall string length. I want to add this thing in the middle at this point, which is that divided by 2. And then you can start manipulating things as necessary. These are basic functions that we can use to do things, but they're pretty context dependent on what you're trying to get done. So we're just going to keep going over these basic commands so that we're getting the thing. So in the print, note that you can also put in other functions, right? So we saw type earlier, and now we're using length. All right, what is the length of this sentence? Okay, this is a sentence, right? We can also make a list of strings. All right, so here we have a list of strings instead of just one string. We have a list. We have string 1, Python is awesome. String 2 is look, I'm programming. And string 3 is E equals MC squared. All right, and so then we can print out the length of the string. But specifically, we're looking at the index, right? So we're looking at one item in that list. Okay, so if we print out the length of just the list of strings, and we'll put that in print. You guys can see I make typos all the time, which is why I rely on tab completion. All right, and so this 3 is because I have 3 separate items in my list. But if I want the length of a string in the item, okay, here I'm going to get number 1 because I want the second item in my list. All right, and that's got 22. Okay, so we're going to be looking at some statements later that would allow us to look at the lengths of all of these and produce a data set with, I have this list of strings, what are my lengths? And then you could compute average string length in this data set, maximum string length, smallest string length, et cetera. So you can start using these things to create data out of the data that you already have. All right, and that's strings. Do we have any questions here? And are we moving too fast, too slow? What kind of gauging do we have here, guys? We got about 5 minutes before our first session is over. So I see some thumbs up. We're tracking along pretty good. All right, people are saying good. Okay, so we'll just keep moving around about this pace then. All right, so now we get to the tuples that we were talking about. these things are immutable, so they can't be changed. All right, so they're surrounded by parentheses. So our list was surrounded by square brackets. Our tuples are going to be surrounded by parentheses. All right, and so they can be used to represent a collection of data. I use them most often for coordinates, whatnot. So here we see that output also shows us, hey, this is a tuple. This thing is not mutable. All right. So this is going to, when the yeah, there's a feedback link in the forum in case you guys need to leave right at 12 o'clock. There is a feedback form there. So there's a good question. How do I print the length of 0, 1, and 2? I'm assuming you mean the items in the list. So right now, all we have is manually changing this number. So we could change this number to 0, and this would give us the length of the first item in the list. And then if we wanted to take the third item in the list, we would change that index to that. So right now, manually is all we have. In the second half, we're gonna start getting into statements. So we have to do some other things first that we don't have access to yet. And we're gonna look at how we can build loops to do all of this and store it as data. And then we could do the calculation of the three strings links. And what we're gonna get to those functions that we can see where that would be useful, and you could add those in. All right. And so here we go. We're gonna say this. So we've made two tuples, one with numbers or coordinates and one with ice cream flavors. And I decide, oh, I want to make, I got a new ice cream flavor. I want to add it to my tuple. And what's going to happen, whereas with list, we could use append and we could add it onto the end. This one's going to give us an error. All right. And it says a tuple object has no attribute append. So we can't use this here because what this is doing is it's giving it an address and it's dedicating space to it. So that way, if you want to find something and use something particular in a computation later, it already has it stored and it's not going to use as much memory to do that, to get to the last item. It knows where that item is stored. So this makes it faster because if it was a list, it would have to go through the entire list. And so, you know, with 3 items, you're not going to notice any difference. But if you're looking at 10,000 items, the processing time is going to get exponentially bigger. So this is where a tuple may be a lot more useful than a list. So the only way to change this tuple and add bubblegum would be come up and say, hey, ice cream flavors, you're going to be a tuple, but now you're going to include bubblegum. And you rewrite it and it redoes this process one time and redoes all of its addressing. And we've added it, but it overwrote. We did not append. Okay, so we took that, we reassigned a new value to the tuple or the variable ice cream flavors. So if you want to modify a tuple, you're going to have to overwrite. Can you create a new column as a copy that can be appended? So right now, we're not working. We haven't actually got even into a table yet. So these are all just, this is just a list. So we could add these into a table. We can create these columns and we can make them columns into a data table or a data frame. But you're going to be, when you combine those things, you're taking the links of your list and stuff that you have, and you're going to put that into one table. So the tuple is just an object that we can use and look at for computational purposes. We can put this tuple into a column, but then it would no longer be a tuple anymore. It would be part of a data frame or a data table. All right, but that's a good question. So if you want to look at the differences, here's a very long drawn out explanation of what this is and how it kind of works. But we're going to skip over this for our purposes because it's not necessary to do what we need to do today. So we have a set. So our set here, we have a list. Okay, and so we see that we have Africa, Europe, North America, Africa, Europe, North America. Okay, and it's contained, we know it's a list because it's contained inside of square brackets. And if I print this, it's going to print out exactly this inside of square brackets. Now, if I took this same set, the same list, and I put it inside of curly brackets and said, hey, this is a set of items. It's the same thing. We're going to get only Africa, Europe, and North America because it's the unique values. So let's take a look. And sure enough, our output matches what we expected. So sets like lists, they are mutable, so we can add, okay? But notice that the method is different, okay? And with a list, we use append. With a set, we use add. And so if we run this, we've added Asia and we've added Europe, okay? And so by adding Europe to our set, it's not going to print because it was already there. So the only new thing that we added, even though we tried to add Europe again, the set is giving us unique values in that set. And so Europe was already there. We can add it 1,000 times if we want to. It's not going to add on to what we have. All right, and so we see that the list has stayed the same because we didn't do anything with it. All right, and we've added Asia to our set. And with that, that's going to end up that data structure, and it is time to break. So we have about an hour break for lunch. We'll be back here at 1 o'clock for another 2 hours, and we'll be picking up right here where we left off for session 2. So thanks for attending this morning, and I hope to see all of you guys back in an hour. And yes, it is the same Zoom link, and there is, could one of the helpers put the link to the feedback form for the morning session in the chat again? So you could fill that out for there, and I will try and take a look at some of that data before the next session starts.